Hey everyone, and welcome to the fourth video in the XDC Report, where we will be going through the latest news and updates in XDC's engineering. My name is Atharva Chandratre, and I'll be your host for this web series. So, for the agenda of this video, we'll first discuss the current state of the XDC network. This means we'll talk about things like the throughput of the current network, the block time, finality, and other parameters about the XDC network. We'll also see how it fares with Ethereum when the numbers are compared for each parameter. And finally, we'll also be talking about what distinguishes XDC's current dPoS, that's the delegated proof of stake consensus mechanism which they have, with the current implementations of consensus mechanisms that other blockchains are using. So let's look at the XDC network's current state and statistics. First of all, the XDC network is a public blockchain. What does that mean? That means that anyone can see the transactions happening on the network and anyone can join and transact on the network without needing any permissions from any authority figure. This also means that anybody can create a node for this particular blockchain and start validating the transactions provided they have the minimum hardware requirements met by the computer they're planning to use. This makes the XDC network extremely transparent, considering the fact that all the code is all online, it's on GitHub, and it's all open source. So the way XDC network validates transactions and adds them to their chain is through being validated by 108 active master nodes. Note that I'm saying the word validated and not mined, and this is because this is a proof of stake consensus mechanism, not proof of work. This is also why XDC is already so energy efficient and fast. Apart from these 108 nodes, there are 90 backup nodes, which can step in to fill the place of any of these 108 nodes if they start to fail. The XDC network also has a 2-second block time. A small block time like this helps to increase the overall throughput capacity of the blockchain. For a block to be included in the blockchain, it must get 2 votes in order to be fully validated. Because it just needs 2 votes, that is, because this is a delegated proof of stake consensus mechanism, the 2-second block time and the extremely high transaction speeds are made possible, which we will speak about in a bit. XDC's network also has a 1000 block finality, which means that the transaction becomes permanent and irrevocably completed in the 1000th block after which it is validated. So if your transaction happened in, let's say, the 10th block, then in the 1010th block, it will guarantee to be permanent and will not be able to be reversed. This is around 2000 seconds, so around half an hour. Finally, the transaction fees are negligible, which is a fraction of a cent to complete one transaction. So XDC's network can be naturally compared with ETH 1.0. At the moment, we are comparing XDC's first consensus mechanism with ETH 1. Comparing these, we can first see that the major difference is the transaction throughput, where XDPoS can handle up to 2000 plus transactions per second. Ethereum's proof of work implementation can handle around 10 to 12 transactions per second. Similarly, block time is different, with XDC being 2 seconds and ETH being 10 to 12 seconds. Finality, therefore, is also different, with XDC needing 1000 blocks for finality, whereas ETH needs at least 6 blocks. At least 6 blocks is the wording given in the official ETH documentation, whereas in practical terms it takes much more than that, pushing the finality time to a bit higher value to around 600 to 800 seconds. This is one of the major upgrades that XDPoS 2.0 is planning, which is decreasing it to a value which is much below what is needed by ETH 1.0 at the moment. Finally, transaction acceptance is such that 2 votes are needed from the master node, whereas in ETH, all nodes mine as proof of work is basically a race to see who can solve the cryptographic block creation puzzle the fastest. Also, the transaction fees are very low in comparison to ETH 1.0, as the transaction fee for an ETH 1.0 transaction can go to around $10 per transaction. So what distinguishes XDC from other top blockchains? Well, it's the technology built into the consensus mechanism, which can be attributed to 3 major things. The first one is the idea of a master node and how they are incentivized. Master nodes are the main nodes in the XDC network which perform transaction validation and adding them to the blocks. They are selected after a rigorous set of minimum requirements, and that ensures system uptime. Secondly, another important feature of the XDC consensus mechanism is the way it's built. It uses a Byzantine fault-tolerant system that makes it already extremely fast and secure, and much faster than normal proof-of-stake consensus mechanisms. The block proposing and voting mechanism is also extremely interesting, and combined with the way the confirmation rule for blocks is built, It allows for a 2-second block time and 1000 block finality, which was explained previously. Since each of these topics are extremely vast and can't be covered in this video, to make the experience better for the viewers, I plan to split this into 3 separate videos, with each one explaining these topics. So that's it for this video, everyone. Thank you all for joining. Until then, this is Athurva Chandratre signing off. Catch you guys in the next one.